Right. So thank you to all of you and for attending this online class. Basically, I just using the apa ni just my smartphone because apa ni my PC is not apa ni tak ada, there is no camera, and also ada apa ni adalah mic and so on. So basically so today kita continue dengan apa ni dengan chapter Rivet, chapter Rivet. So as you can get the question that I post to the group, okay. So kamu boleh tengok, you can get the question from the figures that I show to you in the group. Okay. Right. So basically, so today kita akan continue dengan another example. Okay. Okay. Alright. Boleh nampak tak yang dalam saya punya screen ni? Screen kecil lah. Alright. Maybe we can improve kita punya our online class ni. Alright. Basically, apa yang saya nak share dengan kamu adalah berkenaan dengan topik Rivet. Okay. There is one question. Basically, this question is final exam question. Okay. A bit slow punya line. Okay. Okay. Right. So this is the question. Right. So so we have this figures question. Steel bracket joined by means of 4 equal size rivet on a vertical column. A point load of 5 kN X at the free end of the bracket. Okay. Right. So here's the bracket, and then this is apa ni? Rivet 1, and rivet 1, rivet 1, 2, 3, and then 4, and then we have kemudian suruh determine the centroid among the group of rivet from rivet 4, and then the radial distance of each rivet from centroid, and then the reactional tangential force on each rivet, and the diameter of the rivet if the yield stress of the rivet material is 400 megapascal. Okay, so basically, when you have this question, right? So the first thing that you need to determine is centroid of the group of rivet. So kena cari titik tengah centroid, right? And so that's the first one. Right? So according to the question, so that's the first thing that you need to determine. Okay. Now, then please bear in mind that the rivet mentioned in this question, so maknanya dia punya area of rivet is same. Okay. And then, all right. So this is the the bracket and also the rivet 1, 2, 3, and 4. Okay. Right. So in this case, it's mentioned to us we need to determine the centroid from a rivet number 4. So our reference is a rivet number 4. So this is the rivet number 4. Okay. So so we need to determine the rivet, the centroid from rivet number 4. So what we need to do is, first of all, we use this equation. Okay. X bar equals summation of X bar times A divided by summation of A. All right. So X bar is X1 A1. Okay. X1 A1, X2 A2 plus X3 A3, and then plus X4 A4 divided by A1 plus A2 plus A3 plus A4. Now, X1, what does it mean by X1? X1 is actually distance from rivet number 4 to rivet number 1 in X direction. Okay, X1, I repeat, X1 is the direction, the X direction of rivet number 1 to the reference, ataupun from reference to the rivet number 1. So reference is number 4, rivet number 4. So this is rivet number 1. So in X direction. So meaning that the distance in X, okay, from the reference number 4. So in this case, so rivet number 1 is in line with the rivet number 4. So there is no distance in X. So that's why 0. Satu kosong lah. Sebab apa? Sebab tak ada jarak pun pada arah X kan, di antara rivet 1 and juga rivet 4. And so kita ada 0 X1. Similarly for rivet number 2 kan, dia sebab inline dengan rivet number 4 kan. So there is no X direction distance in X. Okay, so 0. But for rivet number 3, okay, rivet number 3, there is a distance from rivet number 4 about 0.1. Dan dia rivet number 3 is to the right side, so that's why it's a positive lah. Positive 0.1 times A3 plus 0 A4. 0 sebab apa? Sebab reference kan. And rivet number 4 reference dia, so kosong lah. Right, so plus A1 plus A2 plus A3 plus A4. Now we know that identical rivet. Maknanya A1 sama dengan A2 sama dengan A3 sama dengan A4 sama dengan A. Maknanya kita wakilkan, we represent the area for each rivet as A because it's identical rivet. So please take note, please bear in mind that this equation will depends on area. So let's say if identical rivet, maknanya area is the same, so it's okay. But if area is not the same, maknanya mungkin ada kecil, mungkin ada besar, kan? So setiap rivet tu area tak sama, diameter tak sama. So we need to include apa ni di area, and maybe dia bagi apa tu area ni rivet number 1 sekian, rivet number 2 sekian. So kita kena masukkan. But in this case is area is similar, then should be okay lah. Then kita masukkan nilai. So we get 0.1 A over 4A, and then we will get 0.025 meter. So X bar 0.025 meter from rivet number 4. Maknanya apa? Maknanya kedudukan centroid, the centroid position from rivet number 4 is 0.025 to the right. So maknanya dekat lebih kurang macam ni lah. Dan lebih kurang macam ni. Okay, itu adalah apa ni in X. Kemudian in Y. In Y. So sama juga dia punya konsep of apa ni calculation. So Y bar, summation of Y bar A divided by summation of A. So Y1 A1 plus Y2 A2 plus Y3 A3 plus Y4 A4 divided by A1 plus A2 plus A3 plus A4. Right. So again, from rivet number 4. Reference is rivet number 4, which is this one. Okay, so for the position ataupun the distance rivet number 1 from rivet number 4 is 0.2 kan. Ni 0.1 campur dengan 0.1 0.2 lah. Maknanya rivet number 1 ni yang kat atas ni dia 0.2 daripada rivet number 4. Dan dia berada di atas. Bila dia di atas dia adalah positif lah. Positif. So 0.2 A1 plus rivet number 2 is 0.1 above rivet number 4, right? So 0.1 A2 plus again for rivet number 3 is also 0.1 times A3 plus 0, and because it's a reference, so rivet number 4 is a reference, so 0 divided by A1 plus A2 plus A3 plus A4. Again, it's an identical rivet, so the area of each rivet is similar. So we take as a A, and then what we get is 0.4 A divided by 4A, and then we will get 0.1. So Y bar, okay, 0.1 meter. So meaning that the position of centroid in Y is 0.1 from rivet number 4. So around here. So tadi 0.025 kat belakang kat sini lah. Kemudian ketinggian dia 0.1. So ketinggian dekat sini. Alright. Okay, boleh Okay. Right. Okay, so itu adalah centroid. Kemudian dia nak minta kita cari nilai R. R ni apa? Ingat lagi R. Okay, R ni adalah the distance from rivet to the centroid. Distance from rivet to the centroid. So R1 is actually distance from rivet 1 to centroid. So R2 distance from rivet number 2 to the centroid. R3 distance from rivet 3 to the centroid. So this is the centroid. And then R4 is distance from rivet 4 to the centroid. And you can see the dotted line. So this is the line, and the dotted line here, 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 here. Right. So meaning that the distance 0.025 is a centroid from rivet number 4. And in X, and then you get in Y. Okay, how do we determine R1, R2, R3, R4? Again, for R1, so we know that the distance is like this. R1 kan? So we can do a what you call the theorem Pythagoras lah. Kan? So we know that yang ni adalah 0.1. So yang ni ke yang ni daripada sini ke sini is 0.025. So R1 is dia punya hypotenuse. Okay. And so hypotenuse. So that's why kita ada 0.1 squared plus 0.025 squared, and then square root, and then we will get R1. And then for R2, distance dia ini je. Maknanya R2 distance dia adalah 0.025 lah. Right? And then R3 is here. We know that the distance from here to here is 0.1. And so from rivet 2 to the centroid is 0.025. Therefore, distance from rivet 3 to the centroid is 0.1 minus 0.025, and then we will get 0.075 meter. Okay. And then for R4 is distance from rivet number 4 to the centroid. So basically this in X is 0.025, so in Y is 0.1. So 0.1 squared plus 0.025 squared, right? And then square root, and we'll get similar for R1 and R4. Okay. So cuba kamu cari. Please try to calculate R1 and R4, and then you give me the result. You can write the result in the chat with everyone too. Okay. So I just stop the video first, and because I want to write down something. Okay, right. Okay. So now, so basically, if you can see the okay, wait cuba matiin. Right. Okay. All right. So if you can see, I just send you one figures. All right. Boleh dapat jawapan Can you get the answer? R2 equal to R1. Okay, dapat dah. So R1 is apa ni? Berapa R1? R1 0.1031. Okay, thank you Is ini siapa? Alright. Okay. Because right, thank you so is 0.103. Right. Okay, so now kita determine pula the moment. Right. So as you can see in the figures, bila kita from the question is apa ni dalam bentuk false begini, right? So in the question and so the force is 5 kilonewton and then with an angle 30 degree. So bila if when you get this kind of type of load, what you need to do is you have to resolve. You need to resolve first, and you need to resolve in x, dan juga y, and dan juga y. Okay. So that's why here, okay, apa yang saya buat, what I did was I resolve into y and and then in X 5 kilonewton cos T. Okay, boleh. Right. So, bila kita ada macam ni, right? So, the moment, therefore, moment kita ada dua. So, moment because of force in Y dan juga in X. Okay. To force in Y is given by moment due to force Y equal to P times E, right? So P is 5 kilonewton and sine 30. And then E dia adalah apa dia? Ada distance. So distance, sekali lagi, E ni adalah distance daripada from the point of load to the centroid. Ingat itu adalah distance, jarak di antara load dan juga centroid. Load dengan centroid. So we know that the distance is 0.2 here, and then we know that centroid from rivet number 4 is 0.025. So therefore 0.2 minus 0.5 to Y, load Y. Kemudian in X, alright, moment due to force X, 0. So apa 0? Is 0. Yes. We have a force in X, but there is no distance to the, there is no perpendicular distance. And there is no perpendicular distance between X to the centroid. Tak ada perpendicular distance. So, moment pada X sama kosong. So, therefore, we use is moment due to force Y, which is the one that we get here. So what's direction? Direction is in counter, is clockwise direction. Okay, boleh Alright, so now sekarang ni kamu my, okay, right. Before I do this, wait. Okay, boleh Can we proceed? Right. Okay. I know you apa ni, you sometimes you will get connected and disconnected and due to the uh, networking right. So I try to record our lecture today, so hopefully uh, I can share with you right. Baik, after we have determined nilai moment, right? So you get the moment right already, my. Okay, so 473.5. Okay, right. Okay, thank you Right. So now kita selepas kita dapat moment, after we have determined moment, we determine the direction force. Now, as you can see here, how many forces that we have? So we have two forces in Y, one in Y and one in X, betul? Right. So therefore, dia punya reaction, kamu kena ingat untuk direction force, reaction dia for each rivet must also have two. And sekarang ni kita cakap right now we are talking about direction force. We are not talking yet about tangential force, tangential shear force. We only talk about direct shear force. So later on we will determine about tangential shear force, right? So for direct shear force, we have two. One force in X and then one force in Y. So for each rivet, and for each rivet, rivet 1, 2, 3, and 4, they also have two types of direct shear force. One in X direction and another one in Y direction. So that's why for direct shear force in X, we have a Px over 4. So Px, we know that the force in X is 5 kilonewton cos 30 divided by number of rivet is a 4. 4 is number of rivet. Okay, all right. And so Y direction, right? So we have a force in Y, 5 kilonewton sine 30 divided by number of rivet 4. So you will get the value of Py. Kamu cari, so sekarang ni try to determine what is Px and what is Px and what is Py. Right. Okay, so now, okay. Hmm. Right. So px is 1082, 1082.53 Newton. Py is 625. Right. Okay. Okay. Good. Thank you. And then after that, you need to determine um, tangential force. Tadi kita dah, okay, first of all, in terms of forces, kita dah determine. Okay, I repeat again, benda yang kita dah determine is first, kita kena cari centroid. And centroid, maknanya kita kena, we need to determine in X and in Y direction, the centroid. And then after that, we determine the R value, R1, R2, R3, R4, which is the distance from rivet to the centroid. And then after that, we determine moment. And moment, which is force P times dengan perpendicular distance, which is distance from load to the centroid. Alright. And then after that, we determine direct shear force. Now, because of these forces, we have a two in Y and also X. So we determine the value of direct shear force for X and also Y, right? So we have two forces of direct shear force. So now we determine tangential force. All right, tangential flux. So for tangential force, so this is the formula. Please remember this formula. So for rivet number 1, so equal to mr1 divided by plus r2 squared plus r3 squared plus r4 squared. And so m3 r3 for f4 r4. And so could you please determine the value for f1, f2, f3, then you get f4. Right? Okay. So I'm waiting for your answer. Okay. I know some of you may left the meeting, so it's okay. I just apa ni, but apa ni, I tak banyak dah, and just a few steps more and to end our session. Okay, please hold on.
Hello.
Yeah, just write down. Okay. Okay, please determine F1, F2, F3, F4. Dia ada kelas, kamu ada kelas enggak? Okay, how was it? Can you get the question, the answer? Share with everyone if you have the answer. So F1, you get 1639.868. Okay, good. Thank you HN ni dia bagus Cepat dapat. HN siapa sebenarnya ni? HN is Huda Naswa. Okay, thank you very much Okay. Right. Okay, so this is for rivet number one. So rivet number one. So basically, in rivet number one, okay, so we know that from the figures. So this is the figures from from the gas set, the bracket. So we have two forces, direct shear force, Px and Py, kan? And then from there kita akan dapat moment, right? And then this F1 is tangential force, kan? So bila kita keluarkan rivet, okay, when we drew a free body diagram for each rivet, so rivet number one is given by this, okay, whereby we have Px over 4 in x, Py over 4 in y direction. So it's a reactional direction force for x and also y, and also F1, which is a tangential force, reaction tangential force, right? So, so the direction to the right, and then Py over 4 to the is in up direction, okay, because it's depend on the load given to us, right? So because px is to the left, and so the reaction must be to the right, and so for py is downward force, so for the reaction must be upward, okay. And also for F1, the direction of force is like this because so F1 it will create a moment. So F1 times dengan the distance R1. So R1 the distance is like this, and so we know that R1 this is a centroid. So R1 is like this. So it will create a anti-clockwise moment because the moment from the external load is clockwise and clockwise moment, right? So for the reaction of the moment from rivet must be in anti-clockwise. So that's why F1 the force is like this, and because it will create a counterclockwise moment, right? So first of all, we determine the angle, and so I just do the simple one. So mula-mula first we need to determine what is alpha. So alpha, we know that tan alpha is 100 divided by 25. Because sebab apa? Because if you can see from here, for example, we know that the distance from rivet 1 to the centroid in x is 0.025, and then in y is 0.1, and right? And so the angle here is actually tan is 100 divided by 25. So that's why you have a tan alpha 100 over 25, and then you will get alpha, and then we do not want the alpha, we want to the theta, and so we get 90 minus alpha, we get a theta. All right, so theta here. So, and then after that, we do a summation of force in x. All right. So summation of force in x is actually consists of px over 4 that you already determined just now. So it's to the right, so it's positive. So positive px over 4. And then minus, because f1, if you resolve in x, is a to the left, right? To the left. So it's f1 cos theta and cos theta. And then you will get a summation of force in x, and also you will get summation in y. In y we have py over 4 is upward, so so it's a positive. And then Fy sine F1 sine theta is a downward, so it's a negative. It's a negative, right? So we'll get the summation of forces in Y. So after you have determined forces in X and also Y, so we do a resultant of forces. So it represents the shear force for rivet number 1. And so square root summation of force in X squared plus summation of force in Y squared. And then you will get resultant of forces. Okay, boleh Right. So I think that's the end of our lecture for today, because so we still have a rivet 2, 3, and 4, and also what we call the question just now is diameter, and the diameter of rivet if the use stress of majority is 400 megapascal. So I will post another video how to solve this question. Okay, inshallah. Okay, so until now, I leave it to you for the debate number 1, and after that, maybe I can create another video to shoot you how to determine debate number 2, 3, 4, and also determine the diameter of the rivet based on the question given to you. Okay, so I think that's all for now. So again, please ensure your safety, especially with this COVID-19 outbreak. Okay, so hopefully may Allah jauhkan kita daripada segala ni lah, bahaya daripada wabak ni, dan jaga keselamatan diri, and then please make sure your personal hygiene and so on, and then social distance and so on. Okay, so maybe starting from tomorrow, I'm not sure, and the class ke apa ke, there is no so far the direction from VC, so we just wait. But as I mentioned to you, I will try to help you, and especially when solve these problems. Okay. All right. So anyhow, thank you very much for your patience, for your time, and listening to me. And uh, maybe I can prepare a much better online lecture. And so this is just my uh, first time, I would say, and using. So right. So inshallah we will again. Thank you very much. Assalamualaikum warahmatullahi wabarakatuh.